Welcome to this tutorial on outer products in NumPy. Today, we'll explore the np.outer function, a powerful tool for vector multiplication that creates matrices from one-dimensional arrays. An outer product is a mathematical operation that takes two vectors and produces a matrix. Each element in the resulting matrix is calculated by multiplying one element from the first vector with one element from the second vector. The mathematical notation is a tensor product, B equals a sub I times B sub j, where I and j represent the row and column indices. Let's see a concrete example. If we take vector A containing the values 1, 2, 3, and perform an outer product with vector B containing 4, 5, 6, we get a 3 by 3 matrix. The first row contains 4, 5, 6. The second row has 8, 10, 12. And the third row shows 12, 15, 18. Notice how each row is the first vector multiplied by each element of the second vector. The syntax for NumPy's outer product function is straightforward. We call np.outer and pass two parameters, and there's also an optional out parameter that we'll discuss shortly. Let's break down the parameters. Parameter A is the first input vector, which must be a one-dimensional array. Parameter B is the second input vector, also a one-dimensional array. The out parameter is optional and allows you to specify an output array where the result will be stored, which can be useful for memory optimization. Here's a practical example. First, we import NumPy as np. Then we create two arrays, array A with values 1, 2, 3, and array B with values 4, 5, 6. We call np.outer with these two arrays and store the result. Finally, we print the result to see our outer product matrix. When we run this code, we get a 3 by 3 matrix. The output shows 4, 5, 6 in the first row, 8, 10, 12 in the second row, and 12, 15, 18 in the third row. Each row represents vector A scaled by each individual element of vector B. Let's summarize the key points. First, the outer product creates a matrix from two vectors. Second, the shape of the result is the length of A by the length of B third. Each element in the output matrix is the product of corresponding elements from both input vectors. Understanding outer products is essential for linear algebra operations in NumPy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.